Okay, there's a question about how to do a Poisson using just a calculator. In other words, crank this thing out by hand. So let's take a look at that. Okay, this is a magic formula. I'm doing this live so I can use the pointer. But you look at probability of getting whatever number of interests you have times the Poisson mean, which is n times the average, times e, and times the negative of the average, all divided by r factorial. I'll go with that. Well, I'll tell you right now. R is like, if it's 3 or less, it's 3 times 2 times 1. That's what factorial means. And then, of course, there's e. So let's do the example. So you got a continuous process that has about 2% defective. What is the probability that a 100 piece sample contain exactly 2 defectives? So there's our average, n times p, 100 times 0.02, which is 2, and our point of interest is 2, right? So if I plug that into the equation, again, our average, 2, r, 2, e is e, and our average is negative 2. Okay, r factorial will be 2 times 1, or 2, right? Right there it is, times e squared. They're simplified here a bit. That's what that is. So what happens is you do all the numbers, you come up with 0.27 or 27%. If you want to know what the probability of getting 2 or less, you'd have to calculate R0, R1. You'd add these up, so it'd be 27 plus 27, 54 plus 13.5, 67.5. So the odds of getting 2 or less is 67.5 just by random chance. If you wanted 3 or less, you had to add 18 to that. So that'd be 67 plus 18, 85.5%. And if you're going the other way, what's the probability of getting 3 or more? Well, you'd have to calculate 2, or you'd have to calculate 3, 4, 5, on and up until your point of interest. Brings back a lot of bad memories because we used to do this without a calculator. Had tables and things we used. But that's how you calculate Poisson distribution, just with a calculator.